So now in our last video, we took 18 volts and using the TLE2426 virtual ground rail splitter, we split it in half. So that 18 volts, we made ground the halfway point. That'll be the output pin of the rail splitter. And so that's the halfway point, which means the power supply rails. The positive one is now going to be positive 9 volts. That's half of the voltage towards more positive. And then the negative supply rail is going to have negative 9 volts in relationship to ground. So when we flip the switch, I'm just going to move a jumper to the positive rail, but we come to this side of the circuit. We have a current limiting resistor right there, so you can see the current flow there, and then it has to go through the red LED because that side's more positive, and the cathode over here is to ground, which is more negative. Anode towards the more positive side. The blue LED will not light up because the cathode is more positive, the anode more negative. So it's going to block more than about 2 volts. The red LED will light up with that 2 volts. When we flip the switch to the negative rail now, so I'm actually going to use a jumper as we'll see, but when we connect that to the negative rail, it'll be going to the current limiting resistor right there, and then the blue LED will light up because now ground is more positive than the negative rail. Remember, it's the halfway point of 18 volts, and so it will push current through the blue LED. It's going to light up because it's headed towards the more negative side of the circuit. You can see the cathode more negative, anode here more positive. That's 0 volts there. Here is the integrated circuit, and you can see the output is ground. Here we have the circuit on the breadboard. So the TLE2426, the flat side is to the right. You should be able to see that. And so if you swivel it this way, the input's on top, the common is in the middle. So that goes to the negative supply. And then this splits it. You get half the voltage at the output there. That becomes our ground. Now, as I said before, when this side of the circuit's more positive, I want the red LED to light up. So we got the anode to the current limiting resistor, the cathode to our virtual ground. Whereas when this side of the circuit is more negative than ground, I want the blue LED to light up. So short lead the cathode. Down here, long lead the anode to the row that our virtual ground is on. And that is it for the circuit. We have 470 ohm resistor, because even though it's 18 volts, ground is halfway. So if we go to the positive supply right here, now you can see the red LED is lit up, and we only have about 15 milliamps of current approximately flowing through it. The blue LED, I'm going to go to the negative rail. Now it lights up. As I said before, now ground is more positive. The blue LED is lighting up. Again, we're protecting the LEDs with the 470 ohm resistor, because of that 18 volts, only half of it is going to go across either LED at a given time. And so now you can see the blue LED is lit up. So in any case, hopefully that all made sense. I just want to demonstrate mostly that you can alternate the direction that the current flows through a circuit when you have ground halfway between the power supply. So that's splitting the voltage. And you can buy dual power supplies where you have a positive voltage ground and a negative voltage that you can adjust and whatnot. But I don't want to buy one of those. They're fairly expensive. So I just use the TLE2426 integrated circuit to split the rail. So in any case, hope that all made sense. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, all that. Donate Patreon if you can. That helps out the most. I have links down in the description. But just watching videos helps out a ton. Thanks for watching them. I'll see you in the next video.